the gas in it, and what is the gradient inside that container?
You know, I just keep on hearing containers. So, what was your question?
No. What's what's the differential pressure in a Calagas or whatever gas you call it container? What's the differential pressure when you're using the gas out of it? What replaces the pressure? If you're using the
Air.
gas
If you're
out of,
using the gas, the pressure is going to go down.
yeah, it's going to go down. How
Yeah.
does it go down?
Because
What
you're releasing it,
replaces the pressure? What replaces the pressure?
the pressure goes down.
Oh,
Nothing
he's asking
replaces
where
it.
does the gases come from? The earth.
Well, he's
No,
talking
I'm
about
not. No,
inside
I'm
of a
not. I'm asking
container.
what replaces the pressure.
Dude, you're talking about a. Are you
So
talking
it's
about a
What
not a
group
gases are
container?
being
pressurized
used?
container.
What gases are being used?
It's no longer a pressurized container.
Come
If
Not
on,
when you
give
you're
me,
open up
give
the
me,
sucking,
give
valve,
me how
Gary.
the
if you're
gases are being
sucking
used.
all the gas out of it.
Yeah, let's back it up, man. Let's brush up your description of the gas container a little bit here. Are you talking about liquid gas you pour into your car or your lawnmower, or are you talking about like a 200 psi container of compressed oxygen?
You explain to me what Brian and this subject is about.
No, I want you to explain the scenario you're asking us a question about. Are you
Gas
talking about
pressure,
container A or
the
B?
Globes understand it. Gas
Okay,
pressure.
Gary,
So
I want
you
coherence from you,
you
Gary.
explain it.
Gary, I want you to explain the scenario you asked a question about, and then we're going to work on that, okay? So, anyways, are we talking about a plastic gas can that you've got liquid petrol in it and you pour it in your car? Or are we talking about like a compressed 200 psi canister of oxygen, say?
You tell me. It's in the
It's
subject.
your question.
You tell
Which
me.
canister are
It's
you
in the
talking about?
subject of this space.
And
Gas pressure. Do Globes understand it?
Okay, well then let's go with B. Let's say we're talking about a container and it's got 200 psi worth of oxygen in it, say. Doesn't matter. Could be CO2, could be CO, could be fucking anything. Could be acetylene. Anyways, let's say it's oxygen. You with me
No.
now? I got a 200 psi container.
Let's say it's a flammable gas
Who
that
fucking
people
cares? Let's
use
say
for
it's acetylene.
barbecues.
Fine. Fine. Propane. Okay.
Yeah,
Let's say it's
propane.
all gas in there. Fine. There's 200 psi of propane in your container.
oxygen
Okay.
is also flammable.
Let's not worry about how when it's under pressure it turns into a liquid. That's irrelevant. The point is that there's 200 psi worth in the container. That's all we're talking about. Outside, the ambient pressure is still 14.8 psi, right?
I don't give a shit about that.
It's your scenario. I'm just
No,
trying to clarify.
it's this subject's scenario.
It's your scenario that you
No,
just asked a
look at the
question
title
on.
of the space.
You just asked a question, Gary. I'm asking to clarify the scenario around the question. Are you willing to do that? If not, fuck off. Got it?
Why don't you just answer the question?
You
Yeah, your
fixing to
mistake
leave,
was
I need
Gary.
to
engaging with
You
clarify
fixing
Gary.
to
the
leave, Gary.
question.
You gave a scenario. You asked a question about that scenario. And when somebody asks you to
So, uh,
clarify so that they can answer it, you refuse to do it.
So
no,
you
I'm not.
came in here.
No,
You came in here with two other accounts that I blocked, so you can get the fuck out of here. You went ahead
no,
and made a new,
you.
and you went ahead and made a new account just to come in here with this fucking babbling bullshit. Seriously, Gary, this is the best you got. Gas pressure. Do you even understand what the fucking term gas pressure means? Are you
I
talking?
Well,
do.
He's
Yes.
asking
we're
you.
getting to
Are
that.
you talking about filling up your gas tank or a fucking propane tank? Which of those scenarios are you talking about?
So let's the discussions continue.
Which of those scenarios
Answer.
are you talking about, Gary?
Well, we're already into scenario B, where we've got this container.
I
It's
think
got
Gary,
propane with 200 psi in it, right, Gary?
Correct. Yeah.
Okay,
Correct.
great. So when I let the pressure out, all I have to do is open the valve on the container. And because there's more pressure inside the container than outside the container essentially slowly explodes out through the valve as much as you open it at whatever rate you allow that to happen. And it happens because the pressure inside the container is much more than the pressure outside the container. Now, when the
Yeah.
pressure inside the container gets down all the way to 14.8 psi, which is the same as the ambient pressure outside the container, that ends. It equalizes. And it is just like you're either in or outside of the container. You can't really tell because the pressure is the same. So the interaction ends. Does that answer your question?
No,
It's precisely the question you asked.
it doesn't answer my question.
You asked about something being replaced, and the answer is nothing replaces anything in that
So
scenario.
nothing replaces it. So it
No,
becomes
it
a vacuum
equalizes.
then.
No, it equalizes at the ambient temperature.
It empties. It doesn't become a vacuum.
It empties. So what replaces what has been let out of the container?
Nothing, unless you
Nothing.
apply
Oh,
pressure
right.
to
So
it.
nothing. So you've got
So
200 pounds
14.8
of pressure.
psi of propane stays in the tank because it's the same pressure as outside. So it no longer moves
I
from the
think
tank
you all need
to
to
the
Google
outside.
this. I think you all need to Google this because you're completely wrong.
Wow, you're an idiot.
Yeah,
Well,
he's
yeah,
very
you might
close to
say that.
leaving, and he doesn't even realize
That's
it.
what you want to believe.
So why don't you enlighten us? Tell us how this works in there, Gary.
It's quite simple. Do you know how
Well,
simple it is?
we're waiting.
Well, tell us how simple it is.
I vote we ditch Gary and just talk to Swallow. What do you guys think?
Fucking
Immediately,
A.
got
Yeah,
Gary's an
because
office
that's
Fucking
what
fuck.
you
We
Gary.
don't need a
always like
crayon.
to do.
I'm
Hey.
giving him a chance to redeem himself.
Yeah,
Now
that's
or
another
never,
mistake.
Gary.
What's
That's
the
another mistake.
pressure? What's the pressure
No,
in
no,
a
no. You're in
container?
here to tell us how it actually works, because Stone was
Now,
wrong.
what's the,
Remember, Stone
Remember
yeah?
you
Stone
called us
needed to
wrong,
go look
Gary?
it up.
Tell us
Well,
how the right way is.
I've proved you wrong already.
Go
So
ahead.
what's the
You,
Haven't
pressure?
done
you
The
Yeah, go
anything.
pressure's
ahead and tell us
the
what
pressure.
you
how it
didn't
works.
prove us wrong, Gary. You said we were wrong. We're asking you to tell us how it's right. Therefore, if you do this, you might prove us wrong. But until you do this, you haven't done anything but say we're wrong. And saying we're wrong doesn't prove we're wrong. Do you understand the difference there, Gary? So get on it. Jump
Yeah.
frog.
So the pressure's 200, and then you leak it out to fire your barbecue, and it leaks and leaks and leaks and leaks, and the gas disappears, and suddenly there's nothing left inside. So there's no pressure left inside.
Becomes
No,
lighter.
that's not true.
Yes,
It's
it
not that
is.
there's no pressure left
Oh,
inside.
yes, it is.
No, it's not. It is that it reduces to ambient pressure. It equalizes. And
Oh,
that is what
ambient
it says.
pressure. So
Yes,
that means
ambient.
nothing. That
No.
means
No,
nothing.
that means
Are
air.
you how wasted are you, Gary? If I just said 14.8 psi is ambient.
So from
Just ditch him.
Sorry, I
And
did.
I
I had to
thank
get
you.
rid of him.
Thank
He's
you.
being stupid. He's going to pretend like the pressure is zero.
Honestly, I
Yeah,
blame
and
Stone.
it's not.
I blame
Pardon?
Stone. You engaged directly. You asked him a
I am
question. You gave
guilty.
him a chance. Like I don't know what you were doing, dude. I was
I
listening. Like
know.
no,
I
like
know.
Columbo, and he's like it's all about to end, and then he's like, but one more thing, and it goes on for another half an hour. Like I was like excruciating, man.
I've watched all of them, by the way.
Well, that's two Globers now who've misunderstood what air is.
He doesn't even understand what happens with pressurization in the container around ambient with a valve. Like, what the hell is going on with that guy?
So
Wow.
Swalla,
So he was saying that
Wow.
so Swalla,
it's below
what do you
14.
got here? You got
Go ahead.
anything? What do you think
Hey
about
Brian,
gas pressure?
I have to say, I agree more with what Stone was saying than what Gary was saying. I don't
That's why
know
we
what
keep Gary
Gary
around.
was trying to do, but he was all over the place, and I don't know what his point was.
Thank you. Yes, he's a shit disturber.
He's drunk. That's all.
Look, the truth of the matter is that this 200 or 2000 psi tank it was going down to 14.8, as Stone was saying. I agree with that. I don't know why he was saying it was going to zero. I don't think he said to zero. He went to nothing or something like that. But
Yeah, that's what
I
he said.
totally disagree with that.
Good, because that's correct.
The only small addition I have to Stone's thing is the fact that you said exploding, and I don't think it was technically exploding. I thought it was more of an
Well, no.
exhale. Maybe I don't know if there's another
Well,
word for it.
That's why I said very slowly exploding based on how open you set the valve. You know what I mean? If the valve is just creeped, then it's exploding very slowly, but it's still the same definition. It is
Is it
actually
really?
exploding.
I'd be just I don't know. There must be a better word for it. Because sort of term explosion with something that is, I guess, immediate and
Sure.
like damaging.
You could use equalizing because that's what it's doing.
Yeah, obviously, equalizing. Definitely go for equalizing.
It's blowing
Well,
out. doesn't
explosion
on,
is a
you know.
random expansion of gas. Isn't that exactly what's happening?
I think there's an
Perhaps.
uncontrolled aspect to the word explosion that he doesn't like, and I can
Yeah,
identify with that. Sure.
Look, it just sounds a little bit off. That's all. But I
The
mean,
first thing
look,
he said was pressure. He wanted to prove that you were wrong about pressure, right? I mean, that's like the first thing he said. So what was he trying to say? That it's going to go to below the air outside or something?
I don't know what Gary's point was.
Yep.
I think his point was completely base. It was just pointless, and the fact that he wouldn't answer, what sort of gas he actually meant was just I don't know why he's wasting our time.
There you go. See, now you're on Shane's page, and that's right.
I've agreed with Gary on some points in the past, but that one was completely. He was just walking in the dark. I don't know what he was doing.
So if it was a ball, and so Globers believe that the clouds are kept in by some kind of that band going around in the atmosphere and all that.
Oh no,
I mean,
they
there's
think
so
it's
many
all, they think it's all mass attracts mass.
Clouds have their own. Clouds have their own determined sort of. Look, I mean the cloud height is determined on basically on. I don't know what the best way is to describe it.
It's
but
based on the Concordia diagram with a latent heat of vaporization exchange between water vapor and condensation nuclei. That's what it's based on.
It's essentially, I guess, how excited the water vapor is based on how much sort of weight it's sort of terming. Yeah, and so that's why you can have high clouds, you can have mid-range clouds, and you can even have fog down low. It all depends on the temperature and how much material there is and stuff like that. So there's not any one particular thing which is keeping clouds where it is, apart from it's
well, actually, it's air pressure.
Its own
that's keeping
properties.
them there, and keeping them at a particular ceiling that above a certain air pressure that you can't maintain vaporization because of lack of density for one, no nuclei for two, your temperature, like you said, not conducive for three. And it's a bigger thing to do with the jet stream. Swalla, I recommend you check out my Globebusters stream called Electrical Thoughts. By the time I get to the end of it, I also cite and invoke the jet stream and how there is potentially what I see very likely to be an interaction between the ambient electrostatic force that is all around us, the magnetic force that we obviously pick up on our compass, and those are combining in an etherical way to produce the motions at very high altitude, especially that are exceeding 300 miles an hour, and move our winds around as a function of the jet stream. And that it's oscillatory based on an interactive geometric between the sun and the moon's location relative to the surface of the earth itself, and on and on. You should watch it. It's called Electrical Thoughts on Globebusters. I'm sure you'll have some
Does
fun.
that include the air pressure that's actually in the air? So like low pressure,
Yeah.
attracting higher pressures and stuff like that?
Well, I don't know how a low pressure attracts a higher pressure. I think you're talking about surface meteorology there.
Well, yeah, but I mean that's the thing. You would think that most of the air up at the higher jet streams is included in meteorology in a way where, like, if you've got an air column of hot air and it's rising, it's pushing all the air above it, even up to the higher altitudes, and that pushes the higher air around as well.
Could you quantify higher altitudes? Because I'm ready to if you can't.
Well, I mean, anything from 60,000 feet all the way down to like 20,000 feet or whatever like that. So, I mean,
Actually,
if an air column is pushing up from 20,000 to 60,000, it's going to push something up higher.
Actually, it's from surface up to 40,000, and you won't find clouds above that for the reasons that I said.
I'm not talking about clouds.
Okay. Well, air mass movement itself is not really a function of whether it's cloudy. You, of course, were describing, again, what happens as a surface manifestation called a convective cell, where low pressure, high pressure, heating, you know what I mean, air rising, all that cool shit. All that's happening under 40,000 feet. The thing that I'm citing that's moving air really fast as a function of the jet stream is upper atmosphere. And I cite a combinative set of forces which create it. And modulate it.
What was your definition of upper atmosphere? Sorry, is that above 40,000? Is that what you're saying?
Yes, when we're talking about whether there is or is not cloud formation, that's the distinction that I made at roughly 40,000.
I'm going to drop down and come back.
Sure.
Do you think? But yeah, that's where we were going with that one. How did we get there? There was a point before that.
I don't know.
But
it all came from Gary.
I think everyone said that Gary sucks, and we welcome Swalla, and we went to say, how does Swalla prove he lives on a globe?
Yeah, okay, let's go with that.
Well, I didn't think we'd be talking about a globe because today's topic is gas pressure.
Okay, so let's talk about the gravity thing. I remember the point now. All the globies are all talking about. What was that, Shay?
I said touche. You got me. Okay, that's fair.
Okay, cool. And yeah, that's the thing about the mass attracts mass thing, and that's supposed to override the ideal gas law, which describes how gas in its state that it is in, that is at such a high energy level that it, and again, explosively seeks equilibrium until it either finds containment or sharing ambient pressure. And when we talk about the mass attracts mass thing, I was going to kill conspiracy smasher there with Cavendish and stuff, but after that I was going to relate, well, geez, when you talk to the globies about layers and what they call them, the names that they give them, mesosphere, troposphere, ionosphere, way up top they talk about the exosphere, and that begins at about 30,000 feet. Or no, 30,000 miles, I think. It's way the hell up. Yeah, 30,000 miles over the surface of the Earth is where the exosphere begins. And it goes all the way out to like 120,000 miles. And there's still supposed to be a trace, a measurable atmosphere at that distance, halfway to the freaking moon, allegedly. And
that's a pretty low. That would be a very, very, very low amount. I don't know how you'd measure something like that.
That's why they refer to it as the exosphere, is that there's not a lot there, but there's supposed to still be a trace of atmosphere there somehow. X number of molecules per cubic meter, some ridiculous fraction, right? Anyways, the point being that when you look at the old Newton's GMM over R squared thing, and you apply it to this scenario, we're at 30,000 miles from the surface where the radius is only 3959 miles. that old R square really starts to kick the globies in the ass, because when you get to 30,000 miles, you are at roughly 1.3% of 9.81 meters per second squared in terms of an accelerational measurement. That how the fuck
Wow.
is gravity doing its thing at 30,000? Much forget that. How is it doing it at 120,000 when there is no gravity to speak of? They don't like those kinds of questions, but I do like to ask them.
Well, they consider gravity to reduce as per altitude. So the gravity number will go down at those heights, but it would still exist because, I mean, the moon is in the sphere of influence of Earth anyway.
Oh, wow. I can't believe you brought up the moon. That's such a straw man to what I'm talking about. But anyways.
But it is within the sphere of influence.
Okay, well then
in theory.
So 120. Did you say 120,000 miles? That's like
that's the top of
I'm
the
not a third of the way to the moon or something.
It's about half. 240,000 kind of thing. 240.
Yeah, well, I don't think in miles. I think in kilometers. So I'm I'm guessing
400,000, right? Well, let me take you up. Let's see, 120,000 times 0.61.
Must be about 180.
Over 0.61. That puts you at 193,000 kilometers away.
Okay.
Out of
that's still within the distance between us and the moon.
It's just a hair under halfway.
Yeah.
Right.
But I mean, there is still gravity out there. It wouldn't be 9.8 meters per second. It might be like 8. I don't know.
You say. No, I've got it on a spreadsheet, bro. I'm telling you what it is. At 30,000,
so what could it be?
1.3% of little g. You know what I mean? It's diddly squat.
Yeah, and that's probably. I mean, that probably explains why someone they would say that the exosphere gases are probably a little bit less. Attracted? Yeah.
Yes, as in not at all. As in, if they really were a gas out there, they would explosively
1% is still a number
until they reach equilibrium, which is vacuum. That it would just go gone. There's nothing.
Okay, so
it's a gas.
I mean, look, I don't want to obviously derail into so many other bloody topics and stuff like because I want to stick with it.
This is the actual topic.
But I mean, if you got to remember, like when you're saying escape from escape into vacuum, we're also thinking about escape velocity too. So the gas would need to be traveling at some form of escape velocity at the height.
No, you see, that is the argument that the globies give you, but they ignore what they say about the ideal gas law itself. That there's an overarching property to the gas that is being completely ignored when we talk about escape velocity. Okay, that applies to very massive things in a much lower energy state, not things that fall within the little Venn diagram circle of those things that are ideal gases. Like nearly everything on the table.
Then it would stay there, wouldn't it?
No, it wouldn't stay there. It would explosively expand to achieve equilibrium. That's what it does. That's what gases do. They explosively expand
to where?
To space, if that's where they are, if that's what they're in direct contact with, and there's nothing in between.
But if there's still 1%, the gravity factor, then there's still a pulling force.
The point is that gravity really didn't have anything to do with why this stuff is still stuck on the surface. Gravity is only responsible for its direction of stratification, as in from the surface up, densest to least, going upward. Gravity is
so an air particle
it's responsible for stratification, but not for containment.
So an air particle that's 120 miles away will still have 1% attraction towards the Earth's center.
30,000 miles from the surface will have 1.3% of little g applied to it. Yes, but the point is that it is a gas.
So did you? Sorry, sorry, did you have a number for 120,000 miles as you were saying before?
For 120, I'd have to open up my sheet again. I could give it to you. It's a far smaller number. I'm sure you can imagine because we're going according to R squared.
Even if it went down to 0.1%, that's still a 0.1% attractive force towards that versus
but that's
going in the opposite direction. It would need to be going at a speed which exceeds that 0.1%.
See, that's again the Globey lie where they're snaring you with this thing about the necessity for escape velocity, and there is no necessity. Okay, that's where they've got you. They have mind.
But the number of the speed of escape velocity would be lower if the gravity was lower.
Escape velocity is not required in the scenario. It's going to blow straight out towards vacuum. It doesn't give a shit about gravity. It doesn't give a shit what its mass is. It's an energy state that is crucial in the scenario, and you must not ignore that.
Well, still, don't they actually do say that there is a certain amount of loss out of those altitudes? Though?
Out of what loss?
I'm pretty sure that they do say that there is a small amount of loss of gas particles out of those outer areas.
Hydrogen atoms managed to pop out and go to space, and then we seem to trap some more. And what a bunch of bullshit. Okay, I've got your figure for you.
But again, even if it did like escape, even if it did go out beyond the gravity of the Earth, right? It's still within the gravity of the sun's pull as well. So it'll continue to orbit the sun. A particle will continue to orbit the sun with the same velocity that it had from the very beginning.
My man.
Whether or not it's ahead of the Earth or behind the Earth.
Dude, hold that thought right there. I want to get back to you on that, the pull of the sun. But first, I want to give you the figure you asked for. At 30,000 miles, we're at 1.3, 62% of little g. And at 120,000 miles at the top edge of the exosphere, halfway to the moon, it is 0.102% of little g.
Oh, so my guess was actually pretty right then, 0.1%.
Thousandth of the surface force. That's not
but
nothing.
But I did say 0.1%, but my guess was right. But it's still 0.1% pull.
It's diddly squat when we're talking about.
I get that, but what's the pull in the opposite direction?
It doesn't matter.
Zero.
The vacuum of space is supposed to be pulling it in the opposite direction.
But
isn't
0.1 versus 0?
Well,
doesn't it mean that it's going to go towards the 0.1?
The moon and sun were involved.
Let me answer
the moon will have its own pull. That's true.
Let me answer.
But I'm saying that
let me answer your question. It's not about what's pulling on the gas. It's about the fact that the gas is an energy state different than a liquid or a solid. It is a much higher energy state, and it compels itself to blow outward until it equalizes, and it will not equalize with space until it's way gone.
Wouldn't it also cool out in space and lose its energy?
It's not about the temperature of the gas. It's the fact that it is a gas. It may turn to liquid later, and as it blows out through space, I don't know. It just doesn't fit the scenario, my man. We don't see
if it's by itself, it won't turn to a liquid at all.
We don't see a liquid gaseous shell around Earth.
No, of course not.
Right? So forget your theory. It's not evident. Okay? Now, let's go back to this thing you mentioned about the pull of the sun and how that might pull some hydrogen and stuff. And this is all about the mass attracts mass thing that I've been meaning to address. This huge elephant in the room. And again, back to my own video material. In this case, a two-parter. One, a couple thoughts about the moon. And number two is called A Couple More Thoughts About the Moon. They're chronologically posted in reverse chron order on my Rumble page. I strongly recommend you watch them. And in them, I'll let the cat out of the bag now. In the first one, I show how the pull on the moon by the sun is 2.2 times that of the pull of the Earth on the moon. right? Yet at the same time, Earth's or the moon's alleged orbital shape, its ellipticity around Earth, is allegedly only 11% away from perfectly circular. How can that be?
I don't know. I haven't watched this video, so I don't
You
really know.
should, man. I present all of the math, all of the Globee assertions, all of the stuff right off the NASA planetary facts sheet. And then we go to part 2. And part 2 was necessitated out of Globee objection, telling me, gaslighting me, telling me I don't know math, telling me that there's this and that about the vectors that I didn't add up, telling me that I didn't, match up centripetal with centrifugal forces between the three bodies. So that's exactly what I did in part 2. And it's an even worse story than the first one. So I recommend you check both of those out. Couple thoughts about the moon? My treat.
Wouldn't the proximity to Earth have a much higher attractive force in the formulas?
Okay, if we're talking about Newton and we're talking about GMM over R squared, the answer is no. And I quantify.
I would have thought it would have been
the
yes.
answer is. I quantify that the
Because
answer is.
it's mass over distance.
Yes, it is. Now, when you look at the masses and the distances involved, and you believe Newton, and what I state at the end of part 2 is that Newton, in devising this formula of GMM over R squared as proofing when he was working it out, used the sun, the earth, and the moon and put it against his formulae to produce it. Okay? Now, when we do that, the problem is, like I said, the sun's pull on the moon is 2.2 times that of the Earth's pull on the moon. And at the same time, the shape of the moon orbit around Earth is only 11% out of perfectly circular. How can that be?
That doesn't sound true to me, that the sun could have more pull on the moon when
check my math,
when
bro.
you add the distance, because the distance to the sun is so much more vaster that it winds down the
But the size of the
gravity
sun evens that
Swallow.
out.
I get the size of the sun is increased, but the distance is also increased.
What you are displaying right now is zealotry. I present all of the math, all of the figures asserted by what you have in your textbooks on the NASA planetary fact sheet, right? It's their figure, not mine. It's Newton's formula, not mine. I just plug them in.
Well, can you paste that link under something and add me or something like that?
Take your mouse up to me.
I don't have a mouse. I'm on a phone.
Check. Well,
I'm lying on a bed. I'm talking on a phone.
Long press me and pull up my bio, and you'll see my Rumble channel listed. That's how you get there. If you ever forget, I am Flat Earth Man of Stone on Rumble, and there's only one of me.
And you're saying something interesting about the moon? Is that what you're saying?
Have you been paying attention at all?
Well, you said it 10 minutes ago. Is that the correct wording of your video? Yes or no?
There are a couple of thoughts about the moon. I said it twice. Now it's 3 times.
Yeah, but you said it 10 minutes ago.
A couple of thoughts about
a meaning
the moon.
or not?
Somebody asked a question?
Yeah. Is it a hands up space or is it not?
Brian, I don't mean to interrupt.
Yeah, go ahead.
I actually have to go to a birthday party, but I did watch Stone's video. It does appear that the moon has a higher attraction force. But I'm thinking, like, because they're not standstill and they're not falling directly, and they're actually like orbiting in a direction, that sort of knocks out any, like, it's got a sideways force. But that's my own thought. And that
Okay,
damn music. Fuck that music.
Glad you like it.
Too loud.
So you could turn it down, right? It's got a volume
Yeah,
thing.
I did turn it down. It was
Okay,
still
good.
fucking annoying.
Well, that's your problem. I can't help you there, man. But so I'm
That was
guessing you only
horrible
watched.
music, man.
I'm guessing you only watched part 1.
No, I watched. Well, no, I watched both. It was like a 3-minute video. I watched the whole thing.
That's 1, and then there's a couple more thoughts about the moon.
It went through part 1, and then it said it went to part 2. And I looked at the formulas. The formulas seemed pretty correct, but
No,
I don't
there's
really have a lot of
one
time to talk.
video.
I got to put some clothes on and
Dude,
go to a birthday party.
Come on, dude. There's one video called A Couple Thoughts About the Moon, and then there's a whole
Yeah,
other video a couple years later called A Couple More
Is another
Thoughts About the
3-minute
Moon.
video? Okay,
I
yeah,
don't
I
know,
haven't seen
5,
that
6
one yet.
minutes, something like that. That's what I'm
I
saying. I'm
haven't seen
guessing
that
you've
one.
only seen the first one, and that's why you're
Yeah,
saying.
yeah,
what you're
I'm
saying.
reporting on the first one.
That's why you're saying what you're saying. Watch them both. Let me know. Let me know what you think. Go to the party.
It'll
have
have
some
to be in
party.
the comments because it'll have to be in the
We'll still
comments
be here
later
next
because
Friday,
I'm
guy.
going.
We'll still be here next Friday.
If you
guy.
wish, yes.
Like whatever. Can you if you can make it or not? Good. Let me know. Go
We'll
have
see
some
you later,
fun.
guys. Bye.
See ya.